everybody. Today we are going to talk about the last part of the digestive system. We're going to talk about homeostasis. So first, let's remind ourselves what homeostasis is. Homeostasis is the cells or an organism's tendency to maintain a relatively stable internal environment. So what does that mean? That means that your body likes to remain at constant levels and not change. So let's take, for example, temperature. Most people have a fairly constant temperature. It's around 98.6 degrees. It might be a little bit higher, it might be a little bit lower, but it's typically the same all the time. So what happens when you get too hot and your temperature goes up? Your body does what in response? Your body starts to sweat and push the temperature back down. What happens when you get too cold, right? Your temperature dips below normal. What does your body do? Your body starts to shiver and you start to go back to normal. So homeostasis is that normal level that your body likes to remain at. And it's not just for temperature, it's for everything, really. Think about, for example, levels of water, right? There might be times where you drink a lot and you have almost too much water in your body and you urinate, right? So that water level goes down. And there can be times when you don't have enough water, you're dehydrated, so your body will send out signals to let you know that you are thirsty and you drink water and your levels go back up. This is true for salt. So your kidneys help return your sodium levels back down to normal when they're too high. And when we eat, we can help return them to normal if they get too low. Our body likes to have a relatively stable, unchanging environment. And we have mechanisms to make sure that happens. We have mechanisms to counteract any changes, make sure that our body stays the same. Okay, so organisms use homeostasis to maintain a steady state or of internal balance, regardless of the external environment. So regardless of if it's hot or cold or whatever is going on out there. For a given variable, fluctuations above or below a set point serve as a stimulus. These are detected by a sensor and trigger a response. The response returns the variable to the set point that it was originally at. So we're going to use an analogy of a thermostat. So first, we are going to be at a set point in this room. The room likes to be at 20 degrees Celsius. Now, what happens if the temperature outside is really warm and the temperature of the room goes up? Well, typically what happens is the sensor in the thermostat will pick up that the temperature has gone above 20. And what it does is it is going to turn a heater off, or it may even turn an air conditioner on. So we are going to be preventing the room from getting hotter. When that happens, so the air conditioner is on, making the room cooler, the room decreases until we get to what point? Until we get to 20, and then it stops working. The same thing happens if the room starts to get too cold. So it goes below 20. And so something in the thermostat realizes, oh, the temperature went down. Okay, so it's below 20. So what happens? The heating starts, the heater goes on. It starts to cause an increase in temperature. And that increase in temperature is going to stop once the room gets to 20. So 20 is the set point, 20 is homeostasis, and any deviations above or below that are going to cause something to happen, a response. So in the human body, there are two hormones that we're going to talk about today that are going to influence homeostasis. The human body controls its circulating levels of glucose through the use of two hormones secreted by the pancreas. Just to review, what else does the pancreas secrete besides these two things? What else does the pancreas secrete? Yeah, it secreted sodium bicarbonate, it secreted a lipase, and it secreted amylase. And these things were all to help break down food. Those things were secreted into the small intestine. Now, these two chemicals, insulin and glucagon, insulin and glucagon are going to be secreted into the blood, not into the small intestine. So that's a big difference between the two. Let me get the pen out. These are going to go into your blood and not the small intestine. So where they're being secreted is different. So first of all, we have insulin. Insulin is a hormone that reduces your blood levels of glucose. So what does that mean, blood levels of glucose? Well, when you eat something that's very sugary, like a bunch of candy on Halloween, that candy gets broken down by your digestive system, and then one of your organs is going to absorb all of that glucose. Which organ is that? That's your small intestine. Your small intestine absorbs nutrients. So your small intestine is going to absorb the insulin, and the insulin is going to absorb the glucose, and the glucose is going to move into your blood. Once the glucose is in your blood, you have a high blood glucose level, right? So that means now you're not at homeostasis anymore. You've gone too high in terms of blood glucose, and your body wants to push it back down to normal. That is where insulin comes in. Insulin lowers your blood glucose level. And that's why insulin goes in your blood and not the small intestine. Glucagon is a hormone that increases blood levels of glucose. So here, instead of going down, we're talking about going up. When would that happen? When would we need to increase blood glucose levels? Well, if you haven't eaten in a long time, then you might need more glucose in your blood. So glucagon is going to be the hormone that's going to help increase blood glucose level by breaking down stored carbohydrates. So if you haven't eaten in hours and hours and hours and hours and you're getting hungry and your stomach is growling, glucagon may release glucose to help increase your blood glucose levels. All right, so insulin is going to prompt cells to take in glucose. So that means that the glucose is going to go from your blood to your cells. So out of your blood vessels and into your cells. That is what insulin is going to do. Insulin is going to store the glucose as glycogen. So this is our link to last chapter. Glucose is a monosaccharide, monomers. Glycogen is a polysaccharide. So insulin is going to help these monomers get built into a polymer. Glucagon is going to do the exact opposite. Glucagon is going to transform glycogen into glucose. So glucagon is going to take glucose that's in your cells and it's going to put it out into your blood. All right, this is going to happen when you're hungry. You have stored glycogen already from before, from Halloween. You ate too much sugar, and that sugar all got stored as glycogen in your cells. So now you haven't eaten all day, you're starving, your stomach is growling, glucagon is going to come to the rescue and it's going to break up. What type of reaction is that? What type of reaction is going to break up glycogen? That's a hydrolysis reaction. So a hydrolysis reaction is going to break up glycogen into a bunch of monomers. And that's going to happen in response to being hungry. So here we see a view of this happening. So we've got glucose. Let me make sure I have my pen. So we have glucose right there. If you can see where I'm highlighting, the glucose levels are high. And since our glucose levels are high, our body recognizes that and produces these little eyes, which is insulin. So we have high glucose, and therefore we start to produce insulin. The insulin is going to help in picture 2. Notice what insulin is doing. Insulin is taking the glucose and putting it into the cell out of the blood. And meanwhile, it's also helping to build this long chain of glycogen. And notice at the end, picture 4, the last picture, what happened to the glucose in the blood? Notice that the glucose in the blood went way down. There's very little glucose here. And now that we're done, we don't need as much insulin, so our body can stop producing so much insulin. We have effectively lowered blood glucose level. All right, that is called negative feedback. I'm going to write that out here. So negative feedback is going to be when we have a change and the body counteracts that change. I would write that down somewhere in your notes. Negative feedback, when there's a change to the internal environment in your cells, and your body counteracts that change, right? Glucose went up, so we released insulin, and then glucose went down. The opposite is going to happen with glucagon, right? So notice in picture 1, what is the blood glucose level like? Well, I only see one little glucose there, right? So that means our blood glucose level is low, so low G. So since our blood glucose level is so low, that's dangerous, our pancreas is going to secrete glucagon. Glucagon is also a G, so we need to secrete glucagon. I'm going to use a lowercase g. So glucagon comes out when glucose is gone, and notice how it's flooding the bloodstream here. And what is glucagon going to do? It's going to go right into those cells, and it's going to start hydrolyzing glycogen. And notice what's happening over the course. Look at picture 3 and picture 4, right? The glycogen is being cut down, and the glucose that is released is going into the blood. So what happened to our blood glucose levels? Our blood glucose levels went up, and now we don't need so much glucagon anymore. There's a lot of confusing terms there. Glucagon, glucose, glycogen, they all sound very similar. Make sure you can differentiate those. I would go over that tonight. Okay, so now that we've seen the picture, let's review everything that we know. So insulin and glucagon are both examples of negative feedback. Okay, negative feedback is when our cells counteract a change. So we have a particular blood glucose level that we prefer. It's 70 to 110 milligrams per milliliter. So when our blood glucose goes up, our pancreas notices and our pancreas produces insulin. The insulin is going to cause our cells to take up glucose from the blood, and now glucose is leaving the blood, so the blood glucose levels go down, and we return to our set point. That's the normal way that things happen. Let's say we start to dip below the normal blood glucose level because we have skipped a meal. Other cells in your pancreas, alpha cells, are going to realize, hey, there's not enough glucose. Let's produce some glucagon because glucose is gone. And that glucagon is going to go into your cells, and it's going to break up the glycogen into glucose, into monosaccharides, and it's going to transport all that glucose into your blood, causing your blood glucose levels to go back up until it gets to its normal set point, in which case it stops. We can stop producing glucagon now because our blood has returned to normal. And this is what your body does all the time. When you've had too much to eat and when you've had too little to eat, we do this. This is negative feedback. Our body counteracts a change. Insulin pushes blood glucose down. Glucagon pushes blood glucose up. All right, a few questions here to answer. What does glucagon do to the blood, and how does it help maintain homeostasis? And then our second question, describe negative feedback in 1 to 2 sentences. And please answer these questions now. All right, the last thing we are going to talk about is a disorder of insulin and glucagon called diabetes. You may have heard of this before. Diabetes is caused by a deficiency of insulin or a decreased response to insulin. And diabetes is marked by blood glucose levels that are usually too high. There are 2 types of diabetes. There's type 1 diabetes and then type 2. Type 1 diabetes is when your body cannot produce insulin anymore. So there's no insulin being made at all. Our insulin cannot be produced. And type 2 diabetes is when insulin is made, but our body doesn't respond to it anymore. Type 1 is typically going to be genetic. So for type 1, your body isn't going to make insulin. So you would treat that by getting an insulin injection. And type 2 diabetes is usually something people aren't born with, but it's something that people develop through unhealthy eating and exercise habits. People that maybe have gained a lot of weight over time. Type 2 diabetes is usually happens because your body just stops responding to the insulin. And so people typically with type 2, they have to regulate what they eat and how much they eat. They never can eat too much and they never can eat too little. They have to make sure they regulate it to help their bodies maintain homeostasis. And all right, that is where we're going to stop for today. So let me know if you have any questions.